now let's test our knowledge of our exponent rule. So these next few questions are really just a litmus test to see if you know the bare minimum that you need to know about exponents for the GMAT. So this first question is a data sufficiency question that says, is x greater than 0? So just from the prompt, I am sort of being tipped off here that this question is not going to be really about, it's not really an exponent question in the sense we're not going to be expected to solve for an exponent or the power of any exponent. This is really more of a number properties question, because if it's asking me, is x greater than 0, it's really testing my understanding of positivity and negativity and how that relates to exponents, whether your exponent is even or whether your exponent is odd. And so our first statement says x cubed is less than negative 27. And so here we have an odd power, which means the overall value for our exponent is going to retain the sign of our base. So if x cubed is less than negative 27, that means x must also be negative or less than 0. And in this case, so 3 cubed is equal to positive 27. And so negative 3 cubed would be equal to negative 27. Therefore, x must be less than negative 3. If it is going to be more negative than negative 27. And so if x is less than negative 3, x must be negative, and it also definitely must be less than 0. So this is sufficient. So it is sufficient to say no, because the question is asking, is x greater than 0? If we were to diagram this on a number line, our answer here, it would look something like this. So 0 is here and negative 3 is here. X could be anything that is less than negative 3. So you would have an arrow going like this. It is a one-sided solution. Now statement 2 says x squared is greater than 9. And so the properties of even exponents is they are always positive or 0, and they're only 0 when the base is equal to 0. So if x squared must be greater than 9, well, here we have two options for what x can be. So for example, if x is equal to 3, then x squared is equal to 9. And so one option is x can be greater than 3. But when our base here is negative, it's always going to be turned positive because we have an even exponent here. And so we can say the same thing when x is equal to negative 3. X squared will be also equal to 9. And so in this case, if we want x squared to be greater than 9, x must be less than negative 3. So these are two possibilities. So x can be greater than 3 or x can be less than negative 3. So for example, when x is equal to negative 4 squared is equal to 16, which is greater than 9. So if we were to diagram this on a number line, it would look something like this. You have 0 here, 3 here, negative 3 here. Here we would have a two-sided solution. So in this case, we can't forget to answer our question. Our question is x greater than 0? Well, we have values for x that could be greater than 0 and ones that aren't greater than 0. So statement 2 is actually insufficient. And so A is our answer. Next, we have this very short-looking problem-solving question that just says 2 raised to the 24th is. And so it looks like we are going to have to test each of our answer choices, use our exponent rules to see if any of these things are equal to 2 to the 24th. So 2 to the 4th is 2 times 2 to the 12th. So it's really saying 2 to the 4th is equal to 2 times 2 to the 12th. So 2 times 2 to the 12th is just 2 to the 1st times 2 to the 12th. So using our exponent rules, this would be 2 to the 13th. That is not 2 to the 24th. So this is out. 2 times 1 to the 24th. Well, 1 raised to the anything is just going to be 1. So 2 times 1 to the 24th is just the same as 2 times 1, which is just 2. Definitely not equal to 2 to the 24th. 1 more than 2 to the 23rd. So that would be 2 to the 23rd plus 1 here. This is not equal. There's nothing really we can do with this. But whatever this is, it's going to be very, very, very close to the 2 to the 23rd, not 2 to the 24th. So this is out. Now, if you wrote it like this, so this is 2 raised to the 23rd, then that plus 1. If you were to say 2 to the 23rd plus 1, so 23 plus 1 in the power, that would be 2 to the 24th, but that is not what this is saying. Half of 2 to the 48th. So this, I'll do this down here. So 2 to the 48th divided by 2. And this is just 2 to the first. So when we are dividing exponents with the same base, we subtract the powers. So 2 to the 48th, 2 to the 48 minus 1 is just 2 to the 47, not 2 to the 24th. So E is our only answer choice left. Let's confirm that this is in fact equal to 2 to the 24th. So 2 times 2 to the 23rd. So that's just 2 to the first times 2 to the 23rd. We are multiplying exponents with the same base. Add the powers. 2 to the 24th. E is the answer. And now here we have a question that, if you were seeing it for the first time, might look a bit intimidating. After you know your exponent rules, this should be easy though. And so I am just looking to use my exponent rules to combine and cancel as much as I can here in order to get a much simpler result like I have in my answer choices. So we have 2 to the 7th plus 2 to the 7th times the quantity 4 squared, all raised to the 3rd. That over 2 to the 10th times 4 raised to the negative 2nd. So one thing to note here is I have sort of have 2 different types of terms in this fraction. I got these base 2 exponents, and then I have these base 4 exponents. So one thing you might note is that, well, this base 4 is really just a bunch of 2's, because 4 is equal to 2 squares. And so I have a bunch of 2's buried in here. And so if I want to get everything in terms of the same base, I could probably convert this whole thing into just a bunch of 2's, which is how I'm going to end up with something like my answer choices. And this is why, if you are looking to combine or cancel things out, especially when you have exponents, if you break the bases up into their prime factors, you should be able to combine or cancel out. You should be able to see everything that can be combined or canceled out very easily. And so in this case, so if we start with here, we got 2 to the 7th plus 2 to the 7th. So we cannot really use any of our exponent rules here, because here we are adding exponents with the same base. There really is no rule for this, but one thing we can do is, if you just think of this as, this is just x plus x, which should be equal to 2x, except in this case, x happens to be equal to 2 to the 7th. So this is just sort of normal algebraic reasoning. So this should just be equal to 2 times 2 to the 7th, which is 2 to the 8th. We got 2 to the 8th times, so 4 squared. We are raising an exponent to an exponent, so we multiply the powers. So 4 squared raised to the 3rd should just be 4 to the 6th, all over 2 to the 10th times 4 raised to the negative 2. So now we can start using our exponent rules. So we get 2 to the 8th over 2 to the 10th here. And so we are dividing exponents with the same base. So we subtract the powers. So that is just 2 to the negative 2 left up top. Now here we have 4 to the 6th over 4 to the negative 2. And so we got to do 6 minus negative 2. And so in this case, it's really 6 plus 2, and we are left with 4 to the 8th up top. So now we can do what I was alluding to before. So it looks like we're sort of one step away here. We got to find a way to combine my 2's and my 4's into a single base. And we're going to convert our 4 into a bunch of 2's. Because 4 is really just equal to 2 squared. So 4 to the 8th, that's really the same as saying 2 squared to the 8th, which is multiply the powers, 2 to the 16th. So this is just... Now we are just multiplying exponents with the same base. Add the powers 2 to the 14th, which is E. And so these are GMAT questions testing our fundamental knowledge of exponents. Now we will do some medium and hard level questions.